is powers. So if there's no number here, you got to think about that index as being a 2. That'll become the denominator. So xp is raised to the whole number, xp is raised to the 5 over 2. As I said, the index becomes the denominator. So for this one, it's 2 to the 5th, and the index is a 3. It becomes the denominator of the exponent. And this is 3 to the 1, so just leave that. And x to the 4th has an index of 5, so the denominator is 5. We're making entire radicals. For this 3 to come back inside, it comes back inside as a 3 squared. 3 squared is 9. 9 times 12 is, oh my goodness, 108. For the next one, the 2 comes in as 2 squared. 2 squared times 10, which is 4 times 10, and 4 times 10 is 40. So you get the square root of 40. For cubes, when this comes in, for cube roots, then it comes in as 4 cubed times 5. And keep that cube root sign there. And 4 cubed is 64. 64 times 5 is 320. So just make sure that you keep that cube root there. That's often a mistake. And for the last one, negative 2 is on the outside, so negative 2 comes in, and negative 2 gets cubed and multiplied by 2 inside a cube root, and so you get the cube root of negative 2 times negative 2 times negative 2, which is negative 8 times 2, or the cube root of negative 16. We want to find perfect square factors that go into 180, so think about all your perfect squares. One that goes in is 9, but there's actually a bigger one, and the bigger one that goes in is 36. So it's 36 times 5, which is 6 root 5. You want to try and find the biggest one. If you can identify the biggest one, you might have done 9 times 20 and got 3 root 20, but then you have to break this part down into 4 and 5, and then you'll get 3 times 2, which is 6 root 5. So breaking down 192, the largest perfect square factor of 192 is 64, and it's 64 times 3, which is 8 root 3. Again, if you find smaller ones, you're going to have to go through a longer process. For a perfect cube, we could find a number that goes into 128 and is a perfect cube. And the largest of those is, again, 64, and that's times 2. The cube root of 64 is 4, and still inside the cube root is the number 2. For fourth roots, I want 4 numbers that are exactly the same, and that's a factor of 48. And in this case, that's 16, because 16 is made up of 2 times 2 times 2 times 2 times 3. And therefore you get 2 fourth root of 3. 22, we want to identify the irrational numbers, and then we want to order them. The ordering part's easy. If you just calculate what their decimal places are worth, you can order them from smallest to largest, so that's just a calculator question. The identifying which ones are irrational is looking to see if they have a decimal place equivalent that ends or repeats. So this one repeats, so it is rational, and the symbol for rational was a Q. This one involves pi, so it will be irrational. 0.9 square root on your calculator will turn into a decimal that doesn't repeat and never ends, so it is irrational. And the fifth root of 96 also is a decimal that never repeats and never ends, so it is also irrational. So these are your 3 irrational numbers. This is the square root of 18, that's irrational. This is 6, which is definitely rational. This one, the decimal place repeats, so it is rational. And the last one, the cube root of 27 is 3, and 3 times 2 is also 6, so that one is rational. The only one that's irrational is 18 to the 1/2. Differences of rational and irrational numbers, well, they're both real numbers, so that's definitely a similarity. They all exist. But besides that, there aren't too many. They can be written as decimal places or as a decimal equivalent. And after that, we're looking at a lot of differences. All of the rational numbers can be written as a fraction, and the irrational numbers cannot be written as a fraction, and their decimal places for irrationals never repeat and never end, whereas because these can be written as a fraction, the decimals can repeat and they can end. Here's the important points for 24a. We're dealing with a circle, we're dealing with area, and we've got a value for the area of 300 centimeters squared. So the formula is pi r squared, and I know that the area, which is a, is 300. So we did this in the last unit. Divide both sides by pi, and then take the square root. So I use my calculator to calculate the square root of 300 over pi to get my radius. For b, we use the same formula, but now we have a radius of 12, so you can calculate the area using your calculator. It's equivalent to 144 pi centimeters squared. And you can get the decimal approximation of that on your calculator. Hopefully this was helpful, and we'll see you next week.